All right, number 2. So this is the one where you have a skydiver with a mass of 72 kilograms, opens the parachute, initially experiences air resistance of 850. What's the net force after opening the parachute? So draw my person. Okay, here he is. Get his little parachute backpack. This is incredibly well drawn parachute. All right, so then the next step, as always, is to draw all my vertical forces. So applied force, is there something acting on the object? I guess you could technically say the parachute is acting on him, but the parachute is specifically told to me in the problem to be an air resistance force. So I'm going to draw it as an air resistance force. I'm going to write it as F air. If you wrote it as FA, as long as you use the right number, that's fine with me. I'm not going to freak out about that. Likewise, I've had some people ask, well, isn't it tension in the ropes? Well, yeah, the ropes are applying tension, but it's the air resistance that's causing that. So if you call that a tension instead, and as long as you use the right force value, that's also fine. But air resistance is the best one for that one. There's also gravity, because there's always gravity. But that's it. There's no friction. There's no sideways forces. It's just those two forces here. After skipping over the horizontal, since there aren't any, then the next thing to do is the net force. Well, I don't know what the net force is. It's asking me to solve it. So I'm just going to write F net equals question mark. I'm not even going to draw an arrow. I don't know the direction it's in. So I'm just going to write F net equals question mark there. Okay. So now that I've got that, the next thing is to label in the values. Now, the air resistance is 850. And you're wondering, if you are wondering, how did I know air resistance is up? Because air resistance is essentially air friction, and friction is always opposite of the motion. And so because the motion is down, the air resistance has to be opposite of that, which will be up. Okay. All right. When we're labeling in the values, we also want to solve for gravity at this point. So Fg equals mg. The mass is 72 for the skydiver, and G is 9.8. When you solve that out, you get 705.6. Okay. So then it's just a matter of finishing it up. So net force is equal to all the forces added together in that direction. So F net equals force 1, which is my 850 up, plus downward, so negative 705.6. Add that up and we get a net force of 144.4.
Yeah, I was stuck on how like that F net equals F1 plus F2. I didn't know F1. Like I didn't.
Gotcha. You didn't know how to find the net force.
Yeah.
Yeah. So what you do, and this is for every problem, what you do for the net force is it's always, the definition is just all the forces added together. So it's always this F1 plus F2 plus whatever. And
Right.
next class, we're going to talk about how to solve like these full out force problems. And I'm going to give you this equation always, so you don't have to memorize it. I'm going to give you F net equals MA. Okay. And then we'll talk about an easier way to deal with the signs, because sometimes the signs can get kind of tricky. For example, on this, you're thinking, okay, you're slowing down. Why would you have a positive net force if you're slowing down? That doesn't really seem to make sense. I would think you'd be speeding up if you would have a positive net force. So we're going to talk about a better way to deal with signs next time too. But for right now, this is exactly what you would have. You have opposite directions for opposite direction forces. You're adding them together to find the net force, and that's all we're doing for right now.
Okay, thank you.
Any other questions for me on that?